Welcome to the SAF Improvement Hub bite-sized video to introduce Statistical Process Control Charts, or SPCs. Prior to watching this video, you might find it helpful to watch our previous video, An Introduction to Measurement for Improvement. This video explained the importance of variation to improvement work. This session will give a very brief overview of what an SPC is, run through the top 3 rules of an SPC, and let you know where to get more support and information. In improvement, we have 2 terms for variation, common cause and special cause variation. If you think about it in the context of a commute, common cause variation is the differences you would normally expect, such as the traffic lights in our commute which make you a couple of minutes early or late. Special cause variation is when something out of the ordinary happens. Maybe there is an accident that delays your commute and makes it much longer, or you change your workplace and your commute gets quicker. This is the sort of variation we're hoping for when we're looking at improvement. We can only see if this special cause variation has happened if we are measuring something over time. In this bite-sized video, we're going to look at statistical process control charts, which are a great tool to help measure improvement work. So an SPC is a graph with time along the bottom and how much of something up the side. This could be anything: number of referrals to a service, numbers of attendants, percentage of people in a certain amount seen in a certain amount of time. Then for each day, week, month, year, etc., you plot out what value we have, which is the blue line on the attached. Now the difference between a normal line graph and an SPC is the lines or control limits we have. The line in the middle is the average or mean, and the dotted lines are called control limits. These lines are useful as there are SPC rules which link to the lines. When we use an SPC, these rules help us spot when special cause variation, or something statistically odd, has happened. We're going to talk about these lines in a bit more detail now. You may remember this graph from school. It's called the normal distribution curve. The idea of this is that most of the time things will be around the average, and as you get further away from the average, things are less likely. If you think of a room full of people and put them in order of how tall they are, the majority of people would be around average height, and some people would be very small and some people would be very tall. The centre of the normal distribution curve is the average, and what it says is that the majority, 68.2%, will be within one zone of the average. Moving out from the centre, 95% of the population will be within 2 zones of the average, and 99.7%, or almost all of them, will be between 3 zones of the average. What an SPC does is marks out these zones on a graph. If we put the normal distribution curve next to the graph, we can see that 68.2% of points should be within the first zone, 95% should be within the second zone, and almost all of the points should be within the third zone. Most SPCs will only show the average and the upper and lower, top and bottom, control limits, or the third zone. Why these charts are quite cool is because using these lines we can see if statistically anything odd is going on, or if there's any special cause variation when we're doing improvement work. The first rule is that if we have a point outside, above or below these zones, it is odd. Statistically, we would not expect a point to be outside of the control limits, and if it is, there is special cause variation, i.e. something odd has happened. An example of where we might see this is Christmas, when less people are likely to come to the emergency department, or outpatients if you're plotting your commute and there was an accident which caused severe delays. The second rule is that if we have a run of points above or below average, if you watched the previous video, you will have seen us toss a coin 10 times to illustrate that you would not expect to toss 10 heads in a row. On an SPC, you would expect the data to bob above and below average, and having a run of points on one side of the average would be statistically unlikely, or the equivalent of tossing a lot of heads in a row. On an SPC, if you see 7 points in a row one side of the average, this is statistically odd, or special cause variation. The third rule of an SPC is very similar to rule number 2. If we have a run of 7 points going up in a row, or a run of 7 points going down in a row, this is statistically very unlikely, or special cause variation. It is important to remember that in improvement work, we are trying to cause special cause variation. We are hoping to make a change that will improve a system and potentially cause these rules to be triggered. Looking at this example on the screen, can you see any of the rules triggered? The first rule that people normally spot is rule number 1. This is a point below the lower control limit. Statistically, you would expect all of the points to be within the control limits, so a point this low would need investigating. Can you spot any other rules? Rule number 2 is at the end of the graph on the right, with a run of points above average. This might be what we were aiming to achieve with an improvement project. Can you spot any other rules? On this example, this is the hardest to spot. Rule number 3, 7 points going up in a row. It's just before the end, highlighted here. NHSIE have a tool you can use to make SPC charts. The benefit of using these is that they do the control limits for you, and most importantly, highlight where any rules have been triggered so you can easily see when special cause variation has happened. For more information on SPCs, please contact the Improvement Hub or use the National Making Data Count Guide, which is an excellent resource to get more information on measurement for improvement. Thank you for listening.